Hello everyone. In this video we are going to discuss about the topic generation shift sensitivity factor. The previous video we discussed about DC load flow with respect to sensitivity factor. Continuing with the same topic, from DC load flow equation we have for P is equal to B dash into delta, marking it as equation number 1. On interchanging the parameters, we can rewrite it as delta is equal to B dash inverse into P, marking it as equation number 2. For equation number 1, please go back to the video. I have pinned the video in this video here. Please click on the link to get back to the DC load flow for sensitivity factor. And this equation is a linear model where we can easily calculate the change in values for a given set of system conditions. To continue with the same, let us assume the bus power injection change by an amount of delta P. If the bus power P change by an amount of delta P, then the change in bus phase angle del delta is given by, for a change of power P with an amount of delta P, the change in delta will be del delta, and it would be given by del delta is equal to x times delta P, marking it as equation number 3. From the above equation 2, the swing bus power is it is the sum of bus power or the injection of all the other buses, whereas from equation 3 the net change of the swing bus is the sum of net change of all the other buses, and from this we can state that the generation shift factor has ALI is equal to delta FLI divided by delta PI for a small change in power. Okay, where in this expression, marking it as equation number 4, in equation number 4 we can say that ALI is the generation shift factor, and L is the line index, I is the generator index, and delta FLI is the change in megawatt power flow change in megawatt power flow on line L when a change in generation delta Pi occurs at bus I, and we know delta Pi is the change in generation at bus I. Okay, for this equation number 4, we have marked all the parameters listed. For this equation, if we move further to understand how there will be a compensation or how there will be change in generation, it would be easier for us to understand. For that, let us consider a change in a bus power of about plus 1 per unit. Okay, which means here we are having an increase of 1 per unit of power at bus. Okay, let us assume the bus is the ith bus. So in order to compensate this increase in 1 per unit, we'll assume that this compensation or the decrease in to compensate the plus 1 per unit power, will be having a decrease of 1 per unit power at the swing bus. Okay, which means delta P is equal to -1 at swing bus. For an increase of 1 per unit power at bus I, will decrease 1 per unit at the swing bus, which we are taking it as delta P is equal to -1 at swing bus. Thus, if you want to represent it in a matrix form or from the equation number 3, here we are having, for a small change in power, what would be the change in swing bus, and it would be given by delta Pi is equal to XF at swing bus. The delta P is -1, and at bus I, the value of delta P is +1. Okay, and other buses the value is 0, which means the change in power is 0 at other buses. For a change of 1 per unit power at bus I, the swing bus is -1 per unit to compensate that. Okay, which means delta Pi is the change in phase angle for a deviation at bus I. Okay, this is about generation shift sensitivity factor. Okay, if you people have any doubts, so please do message. And the flowchart for the generator shift contingency analysis we'll be having the next video. Okay, please do be connected, and if you have any doubts, please do comment on my comment box. We'll be connected. Thank you.